Now we are looking at functions and mappings. For any mapping, the domain is all the possible inputs and the range is all the possible outputs. A mapping is only a function when every input has one output. So you can have a one-to-one function. And this is like a straight line graph. So f of x equals 2x plus 3. So you put in the x, you multiply it by 2 plus 3, and you get the output. You can also have a many-to-one function. And this is like a quadratic. So f of x equals x squared. So if you put in f of 3, you get 9, and f of negative 3, you also get 9. It's still a function because every input has one output. If you put in 3, you only get 9. If you put in negative 3, you only get 9. So there's many to one. There's two different ways here of getting 9, many ways of getting the 1, but it's still a function because every input has just one output. Something that is not a function, so it is a mapping, but not a function, is a one-to-many. One-to-many. So if it's one-to-many, it's not a function, and we can think of the square root, y equals square root x. So if we put in 9, if the input is 9, so the input is 9, the output, so if we put input 9, the output is either plus 3 or minus 3. So there's one input which gives two outputs, not a function. So functions can be one-to-one, many-to-one, but it's not a function if it's one-to-many. Okay, so state whether the mapping is one-to-one, many-to-one, or one-to-many, and state whether the mapping could represent a function. So the first one, A, we've got every one input gives us one output. There's only one way of getting each output. So it's one-to-one. And it is a function. Part B. Here we can see there's many ways of getting an output. So if you put in either one of these, you get the same output. So it's many ways of getting one. Many-to-one. And it is a function. So as long as every input gives you only one output. So when you put in this number here, say it's 2, you only get out this one output. So it is a function. For C, it is not a function. It's a circle graph. And for this input here, there are two outputs. So this output here, or this output here. So it is a one-to-many. And there it's not a function. And the cubic one for part D. So again, when you put in an input, you only get one output. Every input gives you one result, but there's more than one way of getting the same result. So it's many-to-one, and it is a function. So to be a function, every input has got to have one output. Okay, some for you to try. Pause the video and give it a go. So the first one, this is our square root x graph. It's not a function. It's one-to-many. You put an input in, you put an x in, and you get two y's out. So it's one-to-many. It is not a function. For B, we've got a linear graph. That's a 1-to-1 function. Every input has one output. Part C, this is an x cubed graph, and it's actually a 1-to-1. So if it's a 1-to-1 function, we draw a horizontal line, it's only going to intersect, no matter where we draw the horizontal line, it's only going to intersect once. So it's a 1-to-1 function. And part D, again, we have 1-to-1. You can't draw a horizontal line through and intersect twice. In the same way you can do that to check from many to one, with a vertical line, if it's one to many, it will have two intersections. So if you can do two intersections with a vertical line, it's one to many and not a function. F of x equals sine x. For the domain 0 to 180, sketch the graph of y equals f of x. So the sine graph starts at 0 and it goes up to 1 and then back down to 0 at 180. So state the range of f of x. So the domain is the input, what x can be, between 0 and 180. The output, the y is what the range is. So what can y be? So it can't equal 0 or 180. So it's bigger than 0. And it can equal 1. So it's bigger than 0 and less than or equal to 1. So when it's 90, we get 1. So that is our range. State whether f of x is a 1-to-1 or many-to-1 function. There's more than one way of getting the same answer. So sine 20 is the same as sine 160. Sine 80 is the same as sine 100. So there's more than one way of getting the same answer. So it's many-to-1. You can draw a horizontal line through the graph and intersect twice. One for you to try. Give it a go. So f of x is 2x minus 5 and x is greater than 0. Sketch the graph. So x is greater than 0 and the y-intercept would be at negative 5 and it goes up with a gradient of 2. So it's going to cross here at 2.5. So that is our function. State the range. So for the range, it's going to be anything bigger than negative 5. So it can't actually equal negative 5. So just bigger than negative 5. And it will keep going on forever. So that is our range. Is it 1-to-1 or many-to-1? There's only one way of getting each result, so it's a 1-to-1. F of x is 2 over x. For the domain x is between 0 and 10. Find the range of f of x. So we can't have 2 over x. I'm going to sketch it actually. So between 0 and 10, it's going to look like this. If we put in a really small number, we can get anything really going up. There's no limit to what we can get going up, but it's going to have to be bigger than 2 over 10, which is 1/5. So f of x is going to have to be bigger than 1/5. One for you to try. Give it a go. So f of x equals x squared plus 2x. For the domain 0 to 5, find the range of f of x. So we've got a quadratic, and the minimum point is, so it's not going to matter actually, but I'm going to work it out anyway. So the minimum point is when we complete the square. So it's going to be x plus 1 squared take away 1. So the minimum point is at -1. -1 is the minimum point. So for this quadratic, so -1, -1 is the minimum point. It looks like this. In the domain for 0 to 5, so the lowest thing it's going to be is when x is 0, and the biggest thing it will be is when x is 5. So it's 0, 0. So it's going to be bigger than 0, but less than when x equals 5. So 5 squared, 25, plus 2 more 5s, 35. So f of x can be between 0 and 35. So the range is what the y can be, the domain is what the x can be. So if you put in something between 0 and 5, you can get an answer between 0 and 35. Here's another one. F of x is x squared minus 2x plus 8. For the domain -4 to 4, find the range of f of x. So this time the minimum point will matter. So I'm going to complete the square. X minus 1 squared minus 1 plus 8. X minus 1 squared plus 7. So f of x is x minus 1 squared plus 7. So the minimum point is at 1, 7. So our quadratic looks like this. And how am I going to get the biggest possible answer? If the minimum's at 1, 7, the biggest thing I'm going to get out is if I put in the -4. If I put in the -4, because it's going to be furthest away from the minimum point. It'd be 5 away from the minimum point, where it's only 3 away on the positive side. So if I put in -4, -4 squared is 16, minus 2 -4s. So that'd be plus another 2 4s. So that'll be 24, plus 8 is 32. So it's going to be between 7, which is my minimum of what y can be, and 32 is my maximum. So it's between 7 and 32. One for you to try. Give it a go. So we've got a straight line graph here. So it's 5x plus 1 between 1 and 4. So when x is 1, we're going to get 6 out. So it's going to be 1, 6. When x is 4, we're going to get 21. So 4, 21. There's our function. So what's the range? It's between 6 and 21. And another one. So some different notation here. So f of x, this is just another way of writing f of x. The function f is 3 minus x when x is less than 2, and it's x squared minus 3 when x is greater than or equal to 2. So there's a different equation, different function, when there's different inputs. So depending on the input, we either use the top one for x is less than 2, or the bottom one for x is bigger than or equal to 2. Find f of 5. So if we're putting in 5, we're using the bottom one. So it's 5 squared, take away 3, 25, take away 3 is 22. Sketch f of x and state the range. So there's no limit on the domain. So when x is less than 2, we've got the graph of 3 minus x. So that's got a y-intercept of 3 and a gradient of negative 1. And it goes up to when x is 2, 3 take away 2 is 1. So this point here is 2, 1. Then afterwards, we've got x squared minus 3. When x is 2, x squared minus 3 is 1 as well. And that graph is a quadratic. So its minimum point is at 0. So it comes up like this. So that is our function. Take the range of f of x. So the minimum point's at 2, 1. So we can have f of x can be anything greater than or equal to 1. One for you to try. Pause the video, give it a go. So g of x is x squared plus 1 when x is less than 1. And when x is greater than or equal to 1, it's 1 minus 2x. So they're actually at different places. So we're going to have kind of a gap. So g of 5, firstly. So when x is bigger or equal to 1, we're using the bottom function. So 1 minus 2 5s, 1 minus 10 is negative 9. And sketch g of x. So when x is bigger than 1, we've got x squared plus 1. So x squared plus 1 has got a minimum point at 0, 1. So it's less than 1. So it's kind of going through its minimum point and up. So it's got a minimum point at 1. And when x is 1, it is 2. So that's 1, 2. One minus 2x. When x is bigger or equal to 1. So when x is 1, we're at negative 1. So 1, negative 1. 1, negative 1 is down here. And it's got a gradient of negative 2. So it's like this. So 1, negative 1. And the function keeps going down. State the range of f of x. So f of x can be anything bigger than 1 and less than negative 1. So f of x can be bigger than 1 or f of x can be less than negative 1. So it can equal anything. Can it equal these? It can equal 1. Can it equal negative 1? It can. So it can be anything apart from between 1 and -1.